Hello everyone, our project today is Smart 5G Grid by José Omaña and myself, Michael Santacroce. So what is 5G? 5G, or fifth generation, is the latest wireless technology capable of 1,000 times faster data transmission with the main goal of supporting wireless World Wide Web. Some highlights include high quality and capacity, low cost and low energy consumption, about 90% reduction in network usage, increased connection reliability, fast response with less than 1 millisecond delays, worldwide coverage, longer battery life, and Ultra HD video streaming. Here we have an example of the 5G spectrum. Most people are more familiar with 4G as it goes up to 2.6 gigahertz. Then here we have the subhertz of 5G, it's between 6 and 30, and above 30 gigahertz is the 5G high capacity millimeter wave spectrum. Some problems with 5G include cost and energy consumption are significant. Increased bandwidth, power, and communication overheads need to be taken care of. There's challenges with connection and configuration. Also, it does not travel well through walls and buildings, and signals can be absorbed by plants and rain. So what is smart grid? Smart grid is a power grid that uses communication and information technologies to collect information from the grid. The information is used to modify generation, transmission, transformation, distribution, and consumption of the power in order to increase reliability and reduce costs. On a normal power grid, information is collected on-site manually from devices, but on a smart grid, these devices are monitored and measured remotely. Smart grids can even analyze, modify, and control the power automatically. Some issues with smart grids specifically include deliberate attacks caused by industrial espionage and terrorists, and the inadvertent compromises due to the user errors or equipment failures. The profile then detect method used for ID-DOS attacks increased the detection time. The specifications of the DNP protocol are attained for a nominal user fee, so the man-in-the-middle attacks lead to financial losses and physical dangers. Also, delay performance and data transmission worsens due to long key sizes of public key encryption. Also, host security often depends on device manufacturer, and end users are unable to install security software. This leads to security weaknesses such as wrapping attacks, phishing, metadata spoofing, and injection attacks. Now to Jose to talk more about issues with smart grid.
So some current issues with smart grid as it relates to communications. We have wireless communication is affected by the interference caused by industrial, scientific, and medical frequency bands. Has a lower bandwidth than wire communication, and its penetration range is limited unless consuming high transmitting power. Also suffers from downlink communication, quality of service differentiations, self-healing capabilities, multicasting, cluster-based routing, and network design problems. High voltage electrical equipments can slow down wireless communication or can canish out the signal entirely. Wireless equipment is not readily available for the industrial environment. Next, how can 5G be implemented on smart grid? So 5G slicing divides the 5G network into logically isolated networks, reduce the total cost of ownership since it's easier deployment and cheaper than fiber installations, enables millisecond precise load control, distributed power supplies, intelligent distributed feeder automation, information acquirement of low voltage distribution systems, on-demand network function customization, and automation. Lastly, can achieve security and isolation at the same level as dedicated networks. In this slide, we have an example of 5G network slicing. As you can see, we have the logically isolated networks, starting with wireless broadband, real-time control, Internet of Things sensors, and video streaming. Signals can be transmitted as seen, high bandwidth, ultra low latency, low energy, low bandwidth, and ultra high bandwidth, all going to the same cloud. Now we're going to go over some of the problems with 5G on smart grid. When a cellular tower is damaged, partial or full service is lost in that cell due to the tree-like topology of the cellular network. Services shared by customer markets decrease communication performance of a cellular network in emergency situations for smart grids. The critical smart grid data commands are not delivered before data prioritization and data backup processes implemented in cellular networks. Smart grid utilities do not have the authority of direct control over the communication network since the cellular network providers are responsible for service. An example of 5G smart grid is the 5G standalone based power slicing innovation project, which was a collaboration between China Telecom, a state grid corporation of China, and Huawei, which was initiated in September 2017 and has achieved major breakthroughs in verifying technology feasibility, exploring businesses feasibility, and fostering the ecosystem in Nanjing. In conclusion, 5G smart grid poses new exciting opportunities to reduce costs, but also provides new challenges to currently expanding communication networks. 5G network slices will help build agile and flexible networks and extend services to vertical markets. And lastly, 5G smart grid can address multiple network connection requirements, including millisecond level, ultra low latency, high reliability, isolated networks, and a flexible, coordinated network with ideal capabilities. And that concludes our presentation, Smart 5G Grid.